Hi, welcome to our wireless lab project. We worked on channel computation, an interesting topic useful for improving power consumption in wireless sensor networks. I'm going to briefly introduce you to what we have been doing here. Our purpose was to investigate the received power of the two independent signal transmissions vis-a-vis two concurrent signal transmissions. We used two USRPs for transmission and one for reception. We calculated peaks of received power in both scenarios and came up with a conclusion that concurrent transmissions reduce power consumption. My colleague Bona is going to talk about how we transmit, and Eliakim, who's shooting this video, will talk about the reception of the signals, and Concord, who is here, will tell us more about captured values and our inference.
You cannot have a computation done on the channel without transmitting the signal. Here we have a transmitter TX1. We also have a transmitter TX2. This transmitter is based on the frequency range of 2.4 gigahertz. It's going to be transmitting to the far end receiver. The transmitter is using a USRP component that is communicating with a GNU radio software. It is TX1 and is transmitting at different amplitude with the transmitter TX2.
The receiver is made by a USRP connected to a Rynix client, and the Rynix client is running a GNU radio software. Our receiver block diagram is mainly made by a USRP signal receiver and three sinks: a scope sink, FFT sink, and a number sink, which help us to capture all data in real time. For each experiment round, we are measuring two independent transmissions and one concurrent transmission.
We did an experiment twice, one with a small amplitude which was ranging between 0 and 5. Another part was when the amplitude was above 10 to 300. And the data we captured and put into an Excel file. As you can see, this is for one round. The red line shows the concurrent transmission. The blue line shows independent transmission as the sum of the power at the receiver, which was what we expected. So the difference between them, what we call the error, is the power you could save when you do concurrent transmission instead of the transmitter sending independently. I'm starting at 130.
Okay, Bona, I hope you're not transmitting.
Not transmitting.
Let's see. And down. Okay, 4, 8, 5. Oh yeah, 4, 9, 4. Control stop and
So did you stop?
195.
This is signal transmission with an amplitude of 195.
So what could be the applications of our experiment? As Concord has been showing, we were able to optimize the power consumption on the receiving side in the wireless sensor networks, which could be applied on nodes receiving signals from different transmitters.